Have you ever looked up at the sun and just felt its incredible warmth on your skin? It's a giant fiery star sending us light and heat from 93 million miles away. But what if I told you that we could do more than just enjoy its warmth? What if we could capture that sunlight and turn it into electricity? It sounds like something straight out of a science fiction movie, but it's happening right now, all over the world. This amazing trick is possible thanks to solar panels. They are like magical rectangles that sit on rooftops or in big open fields, quietly soaking up the sun's rays and transforming them into the power that lights up our homes, charges our phones, and runs our video games. It's a real-life superpower for our planet. So, what exactly is a solar panel? If you look at one up close, it might just seem like a dark, shiny piece of glass, but underneath that glass is where the real magic happens. A solar panel is made up of many smaller units called solar cells. Think of it like a giant chocolate bar, where the whole bar is the panel, and each little square is a solar cell. These cells are the tiny engines that do all the hard work. They are specifically designed to be expert sun catchers. The main ingredient inside these cells is a special material that has a unique and powerful ability, a secret ingredient that makes this entire process of turning sunlight into electricity possible. This special ingredient is a material called silicon. You might have heard of Silicon Valley, the famous tech hub in California. Well, it's named after this very element. Silicon is the second most common element on Earth, found in sand and rock. But for solar cells, we use a very pure, specially treated version of it. The scientists and engineers who build solar panels don't just use plain silicon. They add other materials to it in a very specific way, creating a kind of sandwich with different layers. This isn't just any sandwich, though. This one is designed to get very, very excited when sunlight hits it, starting a chain reaction that unlocks the sun's hidden energy. The wonder of this technology is that it's completely silent and has no moving parts. Unlike a big, noisy power plant that burns fuel, a solar panel just sits there, patiently waiting for the sun to rise. It's a clean and quiet way to make energy. Imagine every roof in your neighborhood covered in these shiny panels, each one working like a tiny power station for the family living inside. This isn't just a dream, it's a reality that is growing every single day. We are learning to harness the power of our very own star, a source of energy that is free, abundant, and will be shining for billions of years to come. It's a beautiful and powerful idea that starts with a simple ray of sunshine. Let's dive a little deeper into that special silicon sandwich I mentioned. The material that makes up a solar cell is called a semiconductor. The name itself gives us a clue about what it does. In the world of electricity, some materials are conductors, like copper wires, which let electricity flow through them very easily. Other materials are insulators, like rubber or plastic, which stop electricity completely. A semiconductor is special because it can act like both. It's usually an insulator, but when we give it a little nudge, like a burst of energy from sunlight, it can become a conductor. This ability to switch its behavior is the key to the entire magic trick of solar power. Inside a solar cell, we have two different layers of silicon. Think of it like a peanut butter and jelly sandwich. One layer, let's call it the N layer, has a few extra tiny particles called electrons. You can imagine this layer as having a little too much energy, just waiting for a chance to share it. The other layer, the P layer, is the opposite. It has tiny empty spots where electrons are missing. It's like a puzzle with a few pieces gone, and it really wants to find those missing pieces to feel complete. When these two layers are placed together, they create something called a PN junction, right where they meet. This junction is like a one-way street for electrons. Before any sunlight comes into the picture, some of the extra electrons from the N layer get curious and jump over to fill the empty spots in the P layer right at the border. This movement creates a barrier, an electric field, that acts like a slide. Once this barrier is set up, it prevents any more electrons from crossing over on their own. Everything becomes stable and balanced, just waiting for something to shake things up. This built-in slide is super important. It's patiently waiting to direct traffic once the sun comes out and starts knocking electrons loose. So, why is this setup so brilliant? because it creates a perfect environment for generating an electrical current. We have one side with a surplus of electrons and another side with a deficit, separated by a one-way gate. It's like having a water balloon that's full and ready to burst, but the opening is sealed tight. All it needs is a little bit of external energy to break that seal and let the water, or in our case, the electrons, flow. This clever arrangement, using the unique properties of semiconductors, is the masterpiece of engineering that allows a simple, non-moving object to capture the most powerful energy source we know. Now, let's get to the most exciting part. What happens when sunlight finally hits the solar panel? Sunlight is made of tiny packets of energy called photons. You can think of these photons as billions of tiny, energetic messengers sent from the sun. When these photons travel down and strike the solar cell, they transfer their energy to the silicon atoms. If a photon has enough energy, it can knock an electron right out of its spot in the atom. This is like a cue ball in a game of pool, hitting another ball and sending it flying across the table. Suddenly, we have a free-roaming electron with lots of energy and a hole where it used to be. This is where that electric field we talked about, the one-way slide at the p-n junction, comes into play. As soon as an electron is knocked loose, this built-in slide immediately pushes the electron towards the n layer, the side that already has extra electrons, and pushes the hole towards the p layer, the side that wants more electrons. The field separates them and prevents them from simply finding each other again. This separation is the most crucial step. It ensures that all the freed electrons gather on one side of the cell and all the holes gather on the other. This creates an imbalance of electric charge. Now we have a situation where one side of the solar cell is full of negative charge, all those extra electrons, and the other side is full of positive charge, all those empty holes. This is exactly what a battery does. A battery has a negative terminal and a positive terminal. If you connect them with a wire, the electrons will flow from the negative side to the positive side to balance things out. That flow of electrons is what we call an electric current, or electricity. This is the power that can turn on a light bulb, run a fan, or charge your tablet. The solar cell has effectively become a mini battery that is constantly being recharged by the sun. To capture this electricity, we place metal contacts on the top and bottom of the solar cell. These contacts are like the terminals on a battery. When we connect them to something like a light bulb using wires, we create a complete circuit. The electrons that were pushed to the N layer now have a path to travel. They flow out of the cell, through the wires, light up the bulb, and then travel back to the P layer on the other side, where they can finally reunite with a waiting hole. As long as the sun keeps shining and knocking more electrons loose, this flow continues, and we get a steady stream of clean electricity. It's a beautiful, continuous cycle powered by light. The process of turning sunlight into electricity isn't just a cool science experiment. It's one of the most powerful tools we have to protect our planet. When we generate electricity using solar panels, we don't burn anything. This means no smoke, no soot, and most importantly, no greenhouse gases like carbon dioxide are released into the atmosphere. These are the gases that trap heat and contribute to climate change. By choosing solar energy, we are helping to keep our air clean and our planet healthy. Every single solar panel installed is like planting a small forest that works every day to fight pollution. It's a quiet hero for our environment. The benefits are truly amazing. Did you know that the sun beams more energy onto the Earth in a single hour than all of humanity uses in an entire year? That's an incredible amount of free, untapped power just waiting for us. By covering just a small fraction of the world's deserts with solar panels, we could generate enough electricity to power the entire globe. This makes solar energy not just clean, but also incredibly abundant. Unlike fossil fuels like coal and oil, which are finite and will one day run out, the sun is a source of energy that we can count on for billions of years to come. It's a sustainable choice for generations. As technology gets better and better, solar panels are becoming more efficient and more affordable. This means that more people, communities, and even entire countries can make the switch to clean energy. We are seeing solar panels on the roofs of homes, schools, and businesses. There are even creative ideas like solar-powered roads and windows that can generate electricity. This innovation is paving the way for a future where our energy is not only clean, but also decentralized, meaning we aren't reliant on just a few large power plants. It gives power, quite literally, back to the people. The story of solar power is a story of hope and ingenuity. It shows us how, by understanding the fundamental rules of science, like the magical properties of semiconductors and the energy of a photon, we can create incredible solutions to some of our biggest challenges. It's about looking up at the sun, not just as a source of light and warmth, but as a partner in building a brighter, cleaner, and more sustainable future for everyone. The next time you see the sun shining, remember the amazing journey its light can take to power our world. The magic is real, and it's powered by science.